we're going to evaluate the wrapping function w of pi over 4 and see what point that maps to, some x, y. We want to have actual values here. Okay, pi over 4 is halfway between 0 and pi over 2, so it's right here. This point, let's call this C, and it's going to be x, y. Here's a point A, which has coordinates 1, 0, and here's point B, which has points 0, 1. Now, if we look at the situation we have here, we need to try and come up with points x and y, coordinates x and y. We see that we have arcs here that are equidistant because this is pi over 4, this is pi over 2 minus pi over 4, which would be arc BC. That would also be pi over 4. So we have congruent arcs. BC is congruent to arc CA. Now, because we have our congruent arcs, we can connect the endpoints to those arcs. We now have congruent segments. And because we have congruent segments, that means that the length of those segments are equal. Now that we know that these lengths are equal to each other, we can come up with some distance formula equations, set them equal to each other, and see if we can come up with some type of relationship between x and y. Well, let's do that. Well, BC is equal to the square root of points here and points here. Let's go x minus 0 squared plus the y coordinates squared. Simplify that down just a little bit, and we get to BC, length BC is equal to square root of x squared plus y minus 1 squared. Okay, length CA is equal to, since we have coordinates, we use the distance formula. Let's go x minus 1 quantity squared plus y minus 0 quantity squared. Simplify that down a little bit, and we have x minus 1 y squared. We originally said that the lengths of the segments are equal to each other. Therefore, since BC is equal to this quantity, CA is equal to this quantity, we can set these two quantities equal to each other. Now let's try and come up with a relationship between x and y. So solve for x or for y. And let's just do some math. Well, let's undo the radical, so square both sides. You might be asking, well, could we just said the length BC squared equals x minus 0 quantity squared plus y minus 1 quantity squared? Yes, you could have done that easily also. Do some math here. Y squared minus 2y plus 1 equals x squared minus 2x plus 1 plus y squared. Now take a look what we got here. We have these quantities, this quantities here. We'll start rearranging things and see what happens. Just trying to either solve for y or solve for x. When we start doing that, we notice that I have x squared here, x squared here. If you subtract x squared on both sides, well, those will cancel. Similarly, with your 1 will cancel. Your y squares will cancel. And then you can boil this down to negative 2y equals negative 2x. We'll divide both sides by negative 2 and you end up with y equals x. Now you have a relationship of y or x in terms of the other variable. This is a very easy one, y equals x. Now let's think of another equation that we might have that is an equation that for every point along the outside edge of this circle, that we can eliminate a variable for and then come up with, say, x or y equals some quantity. Well, this is a circle centered at the origin with radius 1 because we're using a unit circle, which has the equation x squared plus y squared equals 1. Well, we know x and y have a relationship right here. X equals y or y equals x. We'll pick whichever one you want to substitute in for. Let's say substitute in for x. So I have y squared plus y squared equals 1. So then 2y squared equals 1. Therefore, y squared equals 1/2. If I take the square root of both sides, I get y equals plus or minus the square root of 1/2, which is y equals 1 over root 2 plus or minus. Rationalize that. Plus or minus root 2 over 2. Well, then you have to stop and think about this for a minute. I have y equals plus or minus root 2. Our y coordinate is in the first quadrant. Therefore, we are only allowed to use the positive value. So, in conclusion, then, I have y equals root 2 over 2. So that's my y coordinate of my ordered pair of the wrapping function w pi over 4, which maps the sum coordinate. I know the y coordinate is root 2 over 2. Well, then how do we figure out the x coordinate? Well, we have an equation that relates x and y together. X equals y. I know the y is root 2 over 2. Therefore, my x coordinate of that point is also root 2 over 2. Now we can think about this and say, well, we define cosine and sine with the wrapping function. What is the cosine of pi over 4? Well, that's the x coordinate of my ordered pair of the point that is mapped to on the outside edge of the circle. What is the y coordinate of my of the ordered pair, which is root 2 over 2, which is equal to sine of pi over 4.